morning class. Today we are going to do a new chapter, chapter 9, motion along a straight line. Alright, now motion along a straight line is divided into three parts: displacement, velocity and acceleration. So today we will just do the first one, displacement. Okay, alright, let's look at the notes. Displacement. Okay, the displacement S of a moving particle from a point O at time t is a function of time. Displacement is a function of time. Okay, so in other words, like sometimes you might get the equation given to you in the question. They may say, okay, S equals to 3t square plus 2t minus 1, something like that. Okay, so there's an equation given to you in the question where displacement is a function of time. Alright, number 2. Displacement is a vector quantity. So vector quantity means it must have magnitude and direction. Okay, so let's say you have a straight line here. This is the x-axis and point O is in the center here. Alright, if the particle moves from here to here, then we would say the displacement of the particle S is equals to 15 meters. Okay, it's how far it has moved. Okay, if the particle moves from O on the opposite direction, that's to the left, to here 12 meters, then its displacement will be equal to negative 12 meters because it has direction. So direction here, we assume direction to the right is positive. Therefore, if the particle moves to the left, direction to the left will be negative. Okay, so if let's say this assume a particle is thrown, you throw a ball up, so it goes up and it comes down. So if we assume that the direction to the going upwards is positive, then the opposite direction would be negative. Alright? Okay, number 3. Now in problem solving, when you do questions later, there are certain things that you got to memorize. Okay? So that when you see these magic words in the question, then you straight away have to use the constraints that we memorized. Okay, let's say this. Okay, these are a few of them. If a particle, now if in the question you see, if a particle is at the right of O, that means right hand side, assuming this side, then we are going to use S greater than 0. In other words, if I use example S greater than 0, and here S is this, for example, 3t square plus 2t minus 1 greater than 0, then this is an inequality. You can factorize and solve it and find the values of t. Okay? You use the inequality method and you can get the range of values of the time. Understand? Okay, if the particle is on the left of O, so if it's on the left side, therefore we will use S less than 0, S less than 0, and we'll do the same thing and find the values of t. Okay, third one. Now if in the question they say at starting point, okay, then we will use t equals 0 because at starting point, that is when we're going to start taking the time. Alright, so when we say starting point, you say, okay, we can use t equals 0 in the question. We sub t 0, t 0, and we can find what is s. Oh, s is negative 1 here. Okay, that means it's 1 meter on the left of O. Example, and then at maximum, minimum or turning point, that means if a particle is moving and then it turns, okay, it reverses its direction. So at this point here, that's called the maximum point, minimum point or turning point. Then we are going to use ds dt equals to 0. ds dt meaning, example, when s is 3t square minus 2t plus 2t minus 1, you differentiate. You will differentiate, so this you will get 6t plus 2, right? And you will put ds dt equals to 0, and you find your time. Okay, that's how you do it. And last one, if a particle passes through O again, that means it's passing through, that means it's coming, let's say, for example, okay, like that, and let's say it started at O. So it has gone here and it turned and it's going to go this way. And at this point, it's passing through O again, right? So when it passes through O again, we will use S equals to 0. Okay, that means this whole equation S equals to 0 and you find the values of t. So that's the time when it passes to O again. Okay, so these are all those things I wrote in the boxes. You have to memorize and use them when you do the questions later. Alright, now we go on to this side. Next one, number 4. 1 minute. Okay. Okay. Number 4. Total distance traveled in the first n seconds. Okay. So to do this question, you have two different methods. So I'm going to show both of them. I will explain how. Okay, method 1 is called the number line method. Alright, number line meaning we need to draw a number line later. Okay, these are the steps you got to do for this question. Okay, let's say I want to find total distance traveled by a particle from the start, okay, when t is 0, it's at 0, to probably we won't put let's say 0 to n lah, n, first n seconds, let's say 7 seconds or something like that. So what do? You must find s at starting point. Okay, first find is displacement at starting point. That means you substitute, because you see this magic word starting point. Just now we memorize here starting point. What to use? We use t equals 0, right? So we will use t 0. We will sub into the equation. Okay, let's say this is the equation. You sub all the t 0 and you get your s. Okay. Now this is an example. Let's say you got answer s is 20 meters. Okay, then next you find s at turning point. So turning point, the magic word is turning point. What do we use? We use ds dt equals 0, right? So you will differentiate the s and you put it equals to 0. Okay, that means example s is equals to let's say the same example like that. Okay, so you do ds dt equals to 60 plus 2, make it 0 and you find the t. Once you got the t, you will sub the t into the s, sub the t there, and you will find the new answer. What is s? Okay, here I forgot this one. Plus minus 1, right? You got this, minus 1, right? Okay. So you got the t already, you sub into the s and you can find the value of s2. Okay, you find t first, then you find s2. Then the third one, find s at ending point. Starting point, turning point and ending point. Okay, so at ending point means, depends on the question, they ask you to find for the first how many seconds. They say first 8 seconds means you will put t equals to 8. First 12 seconds means you will put t equals to 12. Okay, so you sub t equals to 12 into the equation here, dt is 12, and you can find the answer s3. Okay, now let's say I got all these answers. For example, step 4 will be to draw the position of the particle at starting point, turning point and ending point. Okay, so you see this one. Okay, at starting point, s is 20 meters. Okay, therefore let's say 20, no not 20, 12. There's 12, there's 15. Okay, let's say starting point s is 12 meters. So at 12 meters, I draw the particle. Alright, then when you found s2 15 meters, meaning the particle has moved to 15 meters, this is the turning point. Here it turns, and at ending point, the particle is at negative 5 meters, which means on the left, negative 5 meters, so I put the particle here. Alright, so now we see the movement of the particle. It started here, it's going to go here, and then turn and go all the way back to here. Okay, this is called the number line. Okay, now we're going to find total distance from this picture. Okay, what's the total distance? Okay, by looking here, what is the distance from here to here? Here to here is 15 minus 12. That is 3 meters, right? 3 meters. And then from here to here. What's the distance here to here? This is the whole thing. So you see here is 15, here to here is 15, plus here to here is 5. So 15 plus 5, totally 20 meters, right? So totally the distance here is from here to here is 20 meters, here is 3 meters. So your total distance will be 3 meters plus 20 meters. And you get the answer 23 meters. Okay, so this is called the number line method. Remember, you must find 1, 2, 3 S values. After you find the 3 S values, put it on the picture and draw the position and draw the number line. After that, you can find total distance traveled in the first and seconds. Hope you all are okay here. Alright. Now, second method. Okay, we have two methods of doing this total distance traveled. Okay. Second method is a graph method. You need to draw the graph of S versus T. Alright. Now, you would be given the formula. Okay. Let's say they gave you S is equals to 3t square minus 2t plus 2t minus 1. What you will do is, you will form a table and they ask you to find the total distance traveled in the first 7 seconds. Meaning, you have to draw from 0 to 7. So what you do? 0, 1, 2, 3, 4, 5, 6 until 7. Okay? You have to draw from 0 to 7. This is given in the question. This equation also given in the question. Alright, so what you do, you sub one by one. When t is 0, you put t 0, 0 and you got answer negative. Okay, here I just example you got, let's say you got 12. Okay, then when you put t is 1, you get the s, t is 2, all the values until 7, you sub in and you got the values. Okay, once you're done, you got to plot the graph on a graph paper for s against t. So your axis s against t. Alright, so you plot 0, 12. Okay, 0, 12 here. And then you go on plotting, you get all the points here and you get everything here, right? Like that. Then you draw the curve. Okay, after you draw the curve, you want to find what's the total distance traveled. That one will be the height from here to here. Okay, that means you take this height. How far is it from 12 to 15? 3 meters. And from the top, okay, from here to the bottom, this height. This height would be 15 plus 5, so 20 meters. Then you go back and write down 3 plus 20 is equivalent to 23 meters. That's it. Same thing, same answer. Huh? Just showing you example. Okay, so I would say between the two methods, this one you need to really find all the values and plot a graph. It will take time, right? So I would say this would be a faster method. Okay, so you can either choose either one, but I would recommend you to use number line method because it's faster. You don't need a graph paper, you don't need to plot all the points, and you don't need to, it takes time. Alright? Okay, now we go on to the next, number 5. One last one. You're going to find number 5, distance Alright, now we look at number 5. Okay, the last one. Distance traveled in the nth second. Okay, distance traveled in the nth second means we only want to know, for example, this is the number line. Okay, let's say I want to know distance traveled in the 5th second. 5th second means here is 5 and here is t is 5 and here is t is 4. Okay, you only want to know this distance from here to here. What is it? Not from the start. Alright, so for that we will do Sn minus Sn minus 1. Example, 5 second, S5 minus S4. Okay, so you will put now S5, you just have to substitute all the t's here with 5. Okay, so you got this. And minus S4, you substitute all the t's with 4. When you calculate this, you will get your answer. This is the distance travelled in the nth second. It's not from the start. Okay, it's different from number 4. Okay, so that's about it for notes. Okay, now I'm going to show you a question, how we apply what we have learned to solve problems. Okay, can we give you an example and we will discuss it here. Okay. Example, we have a particle moves Alright, so you are given this equation. Okay, therefore you have to find what? A. When you read the question, you need to identify what is it you want to find and what is given. Two things, okay? What is given here in the question and what you want to find. Alright, first of all, you want to find the displacement. That means you want to find what is S at 8 seconds. This is given, that means when t is 8. Okay, so you need to identify first what you want to find and what is given in the question. Now we can do the question. Alright, you want to find S when t equals to 8. All you need to do is substitute. Okay, S is equals to 4t minus t squared plus 12, right? So we sub t equals to 8. See, t equals to 8, we sub it here. So you can find 4 times 8 minus 8 squared plus 12 and you will get the answer. Okay, negative 20. What does the negative here show? Negative here shows that the particle is on the left of O. So you can write down your conclusion. Okay, the particle is 20 meters on the left of O. Okay, so the word left here, no need to put negative. Okay, you got negative, no need to put negative there. So that's your conclusion for question A. Okay, now we go to next one, question B. Okay, part B. When will the particle be at 60 meters on the right? Oh, okay. So this is the question. So let's see what are they asking for. Okay, now when? This is your question. That means what is the time? When means what's the time when will the particle be at 16 meters on the right of O? So this is the S that we are given. So this is what you have to find, and this is what is given. So what you do? Again we do substitution method. Okay, we sub S equals 16 into the same equation. Okay, let me write it down this way. Equals to S, right? Okay, we sub S equals to 16. So we get 40, or maybe I should rearrange this. Put the t square in front. Negative plus 40 minus plus 12 equals to 16. Now I bring the 16 over here and I will times everything by negative. Okay, times all by negative to make this positive. So it will be minus 40. Now this one, when it comes this side, it will become plus 4. Okay, to make a quadratic equation, so that now we can just factorize it. Okay, t, and it is minus 2. Okay, and therefore you got t is equal to 2 seconds, and that's the answer. Okay, can you see that? You're looking for t. When means what is t? What is t? So I've done it. Okay, you just sub S is 16 into the equation, and you get a quadratic equation, factorize, and you find the value of t. So that's how you do part B. Okay, now I'm going to go on to part C. Okay, I'll just erase this. Continue here. Alright. Okay, now in part C. When will the particle pass through O again? Okay, this is a question. Okay, what do we get here? What is given and what do you want to find? Okay, when again? When means again, what is the time? Okay, when the particle passes through O again. Now, you look at the notes that I've given you. Passes through O again means we use S equals to 0 here. This is what you're supposed to use for this question. So, you want to find what is T when S equals to 0. So, substitution again into the equation. The original S equation is given. You sub S equals 0 here. Okay, so you get 40 minus t squared plus 12 equals to 0. Then we arrange it in the quadratic form and we times to negative. We make this positive. We arrange it in the quadratic form and times all with negative, so it became like this. Factorize. Okay, we factorize. We get t minus 6 and t plus 2. Okay, let's check. Yeah, correct. So here I'll get t is 6 and t is negative 2, right? Okay, two answers. Okay, so t is 6 and t is negative 2. Is it possible to have a time, negative time? Can you say, oh, it's negative 2 seconds now? No such thing, right? So we will ignore this because t cannot be negative, and therefore your final answer is this. T equals to 6. Alright? T equals to 6. Alright? Okay. Next one. D. Question D. Okay, let's say find the range Okay. Alright. So what do you want to find here? Find the range of values of t. So in other words, I want to find, okay, let's identify what is what you want to find and what is given. Find the range of values of t. Okay, so this is what I want. What is t? That means from what to what range? Range, okay. T is from where to where? When it is on the left of O. Okay, particle on the left of O, go back to the notes and see what you have to use. When they say left of O, we use S is less than 0. This is what we're supposed to use. When the particle is on the left of O, we are going to use this. S is less than 0. So we sub the S with the equation given. So 4t minus t squared plus 12 less than 0. Now this is an inequality. So we got to do it the inequality way. How do you solve a problem? Okay, first we arrange it, okay, in a quadratic form. Now, can you see the t squared is negative? We get rid of the negative, we times negative for the whole equation. Now, when you times negative for the whole equation, you will get, then you must change the symbol here. Okay, when you times negative with the whole equation, the symbol will change. Okay, symbol will change. Now, for inequality questions, we will factorize. Okay, so this looks like 6 and 2 again. Okay, now inequality questions, you can use this method. Remember, so here I get 6 and negative 2, right? 6 and 2. So you put your negative here and your 6 here. Then you look at the symbol greater than. If it's greater than, we are supposed to shade above. Okay, which area falls above the axis? This part and this part. So this is the area. Okay, this is the inequality method. So from here, we now get the answer. This area is t greater than less than negative 2 and t more than 6, right? This area. Okay, so of course this is, you cancel because t cannot be negative. So your final answer will be t is more than 6. This one is your answer. Okay, because t cannot be negative. Alright, next we are going to do E. A little bit more and then we are done. Show you every example. Okay, question E. Question E is find the total distance traveled in the first, say, 6 seconds. Okay? Okay. So what is given and what do you want to find? Okay. Find total distance. Okay, we need to find total distance. In the first 6 seconds, that means from t is from 0 to 6. This is given. Okay, first 6 seconds, t0 to 6. Okay, as I told you earlier, there are 2 methods to do this, to find total distance. So we will use the number line method, which is a bit easier. Okay. Okay, first, step 1, you must find at starting point. Okay, at starting point, we use t equals to 0. Then we get the equation s equals to 4t minus t squared plus 12. So I'm going to sub t0. Okay, sub it here. I'll get 0, 0. Okay, like that. So answer is 12 meters. Okay, this is S1. Okay, now second, at turning point, we're going to find ds dt equals to 0. We're going to use this. Okay, so what you do from here, we will find ds dt. Okay, 40 squared, 40 becomes 4 minus 2t. Okay, this is your ds dt. Equals to 0, so we put it as equals to 0, and you get find the t. T is equals to 2 seconds. Okay, but we don't want to find t only. We want to find s. Okay, so we have to now sub into the S equation here. You sub the t equals to 2. Okay, you sub it in here. So this is your S equation, right? Sub here, when t is 2, put the 2 here. 4 times 2 minus 2 squared plus 12. And you come to the answer 16 meters. Okay? And finally, number 3 is at ending point. Okay, where does it end? First 6 seconds. So when t is 6. When t equals to 6, okay, this is it. So what you do, you sub 6 inside the t here, okay? Minus 6 squared plus 12, and you got your answer. Okay, 0 meters. Okay, we got 3 answers now. Okay, so what you do, you draw the number line. Okay, let's say 0 here. So at the starting point, the particle is at 12 meters. That means on the right, so here is 12 meters, particle is here. Okay. Then at turning point, okay, we got S equals to 16, which means here, let's say here. Particle has gone here and turned here, right? It's here, 16. Okay. And then at ending point, particle is at 0, meaning here. Okay, that means it has come and stopped here. So this is my movement of the particle throughout the journey. Okay, from 0 to 6 seconds. Okay, now total distance traveled. We will just calculate. Total distance traveled, step 4, will be here to here. Okay, from 12 to 16 is 4 meters. Right, 16 minus 12, and from here right up to here is from here to here is 16 meters. Right, from 0 to 16. So total is 4 plus 16 equal to 20 meters. So that's how you do this question. Okay. And lastly, okay, we go to the last part. So this is all done. And question F. Alright. Okay. Distance traveled in, let's say, in the 7th second. Alright, this one, distance traveled in the 7th second. Okay, only 7 seconds, so it will be S7 minus S6. There's always one before it. And this is simple. S7 means you substitute all the t with 7. So you get 4 times 7 minus 7 squared plus 12. This is S7. Okay, just substitute the t with 7 from here. 7, 7. And S6, you substitute the t's with 6. So you get 4 times 6 minus 6 squared plus 12. Okay? You calculate this. Yeah, I forgot something. You have to put modulus here. Okay, so because sometimes the answer is -9. And sometimes, you get the answer is negative, but you have to make it positive. Okay, so that's answer. Because distance, you cannot say, oh, negative also. So it's not displacement, Displacement, yes, you get positive and negative. Okay, positive to the right, negative to the left. That is displacement. But distance traveled, you don't see positive, negative. How far have you gone all the way? Okay, so that's why we have modulus. In case the answer is negative, it will become positive. Okay, so I have covered everything here. So I hope you all understand this example, and from here you can already do the questions. So actually this topic is easy. You got to just remember what to use. Okay, you must look at for the magic word. Okay, look at the notes, memorize and see what to use, and that's it. It's quite easy. Okay, thank you very much. We'll continue our velocity in the next lesson. Okay, bye for now.